So the first section that we're going to look at with this unit is translating into symbolic form. And the learning target that we're going to keep in mind during this section is I can translate verbal arguments into symbolic form using symbols of formal logic. So we're going to take sentences and compound statements, and we're going to turn them into a mathematical symbol. We're going to talk about what those symbols are and how to use them. So in the math world, we have statements just like there are statements in English. For us, a statement is a sentence that is either true or false. And depending upon what it is, will mean different things. When we say a statement is true or false, that's called the truth value of our statement. And that's going to be really important to keep in mind for this entire section. When we're taking a statement, we're going to represent it with a letter. In the math world, for some reason, they chose P and Q. I'm not sure why they chose P and Q, but P and Q are what we're using to represent statements. So with our example, we have the statement P is supplementary angles have a sum of 180 degrees. And we know that that is true, so our truth value is T for true. We also have negations, and a negation is a statement that has the opposite truth value. When we write this out, we're going to use this little squiggle symbol, and it's going to go right in front of the letter, and we're going to read that as a not. So down here where it says example, this is read as not P. And not P is supplementary angles do not have a sum of 180 degrees. We know that that is false, so our truth value is F. So that's just the basic statement and negation. We're now going to look at compound statements, so putting different things together. So a compound statement is two or more statements joined by the words and or, and those are going to be very important for us to remember. So a conjunction are statements joined by the word and. When we write it out, we have P and Q as two different statements, and we're going to put this little caret in the middle, and that caret means and. So we read this as P and Q. Now, when we talk about the truth value of a conjunction, it's true when both statements are true. So P has to be true and Q has to be true in order for the whole thing to be true. That's for a conjunction. Now, a disjunction are statements that are joined by the word or. We're still going to use P and Q as our statements, but instead we're going to flip that arrow down, and this is read as P or Q. For our truth value for a disjunction, it can be true when at least one of the statements is true. So only one of P or Q has to be true. They can both be true, but one of them has to be true. So let's go ahead and look at some examples. We have the three different statements, and we're going to look at the different compound statements that they want us to write out. So the first statement is there are 7 days in a week. The next is March has 30 days, and then the last is Halloween is on October 31st. Now, as you can see, we've already marked whether they are true or false. Doing this at the beginning will help you figure out what the truth value of these compound statements is going to be. So we know that there are 7 days in a week, so that's true. March doesn't have 30 days, it has 31, so that's false. And then Halloween is on October 31st. So again, that is true. When we're writing it out, we're going to take it one part at a time. So if I have P and Q, I'm going to write out the statement of P, I'm going to write and then I'm going to write the statement of Q. So that's going to look like there are 7 days in a week and March has 30 days. So I'm just writing it all out. If you want to shorthand this, you can, but you need to make sure that we have the important parts. So 7 days in a week, March has 30 days. When we look at the truth value, remember that the and symbol means that we have to have both statements as true. Well, we know that P is true, but Q is false, which means the truth value for this conjunction is also false, because not both statements are true. Number 2, we're going to do the same way. We're going to write out Q, we're going to write and then we're going to write out are. And that's going to look like March has 30 days and Halloween is on October 31st. Again, to figure out the truth value of the whole compound statement, we're going to look at the truth value of the two separate parts. Since one of them is false, this March has 30 days is false, we can go ahead and say that the truth value of the whole thing is false. Number 3, we have P and R. So there are 7 days in a week, and Halloween is on October 31st. Now in this case, we already know that P and R are both true. And since they're both true for an and statement, we have the whole statement is true. Number 4, we have this not symbol in front. So we're negating P, and we have not P and Q. When we're doing not P, we're just going to put a not in our statement. So we're going to have there are not 7 days in a week and March is 30 days. Once we negate this, that means we're having the opposite truth value. So before normal P was true, we know that not P, there are not 7 days in a week, is false. Both of these statements are false, and we need them both to be true if we want a true truth value. So our entire truth value is false. Couple more examples with our P, Q, and R. So now we're looking at some OR statements. So the first one is P or R. So there are 7 days in a week, or Halloween is on October 31st. Now remember, for the truth value for an OR statement, only one of our statements has to be true. So there are 7 days in a week is true. The Halloween is on October 31st is also true. So we have a true truth value for this compound disjunction. Number 6, we have not Q or R. So not Q is going to be March does not have 30 days, and R is going to be Halloween is on October 31st. Again, we just need one of them to be true in order for the whole thing to be true. So when we look at this, March does not have 30 days is true, and Halloween is on October 31st is also true. So this truth value is true. Number 7, we're doing not P or not R. That means both of our statements are going to have a not in front of it, or in it. So we have there are not 7 days in a week, or Halloween is not on October 31st. There are not 7 days in a week is false, and Halloween is on October 31st, which is also false. So since neither one of them is true, this whole statement is false. Last one is not P or not Q. Again, we're negating both statements. So we have there are not 7 days in a week, or March does not have 30 days. When we do not P, that's false, but not Q, March does not have 30 days, gives us a true truth value for that statement. So this truth value is going to be true. So as you can see, it's way easier to get a true truth value for our OR statements since only one of them has to be true.